Hello, welcome back. Still doing two-car problems. And in this one, two cars are 300 miles apart and both are moving towards each other at 50 miles an hour. Car 2 leaves 1 hour later than car 1. Find the amount of time each car spent on the road and find the distances each car drove when they are at the point that they meet. So what do we know? We know this is D. The distance they are apart, and we're given that as 300 miles. Here's car 1, car 2, and D1 and D2. So what do we know about these cars? We got V1, D1, and T1. We know V1 is 50 miles an hour, and we don't know D1, and we'll have to figure out the time. And for car 2, V2, D2, T2, and V2 is 50 miles an hour also. Don't know the distance, and we'll figure out the time. What else do we know? We know D1 plus D2 equals 300 miles. Car 2 leaves 1 hour later than car 1. So again, car 2 is sitting there doing nothing, and car 1 goes for an hour. And let's say this is the hour mark. And there you can write 1 hour so far for car 1. And the rest of the way, it's the same as what D2 is, because car 2 at that moment starts moving and car 1 is still moving, and they'll be on the road the same amount of time. So the rest of the way for car 1 will equal the same amount of time that car 2 does. So you can write T2 as the rest of the way for car 1. And we'll put this down here in other things that we know. And we use our usual D equals VT. And we know the total distance equals D1 plus D2. It says 300. And replacing D1 with V1 T1. And D2, replace that with V2 T2. So we have 300. We have V1. And we can replace T1 with 1 plus T2. And plus V2, T2 stays the same. And expand this out, we have V1 plus V1 T2 plus V2 and T2. We can bring a V1 over here, so this side will be 300 minus V1 equals, and we'll have V1 T2 plus V2 T2 on this side, and we can factor out a T2, and left with the V1 plus V2. Divide both sides by V1 plus V2, and I bring the thing over to the left side like I always do. We'll have 300 minus V1 divided by V1 plus V2. And stick in some numbers. We get 300 minus 50 divided by 50 plus 50. T2 is 250 over 100. And simplifying that, we'll get T2 equals 5 half hours. The car 2 is on the road for 5 half hours, and we know that T1 equals 1 hour plus T2, so T1 would be 7 half hours. And what else did the problem call for? Find the amount of time each car spent on the road. We got that. Car 2 is 5.5 hours and car 1 is 7.5 hours. And the distance each car drove. And just go back to the original equation, d equals vt. For car 2, we got d equals 50 times 5 halves. So d equals 125 miles. D2. And D1 equals V1 T1 plus 50 times 7 halves. And D1 equals 175 miles. If you add D1 and D2, you'll find that it comes out to 300 miles, just like the problem gave us at the beginning. This problem, we have two cars 500 miles apart, and they're heading for each other, and they both start at 4 p.m. Car 1 is traveling at 55 miles per hour, and car 2 is going 63 miles per hour. What time is it when they pass each other? So this is distance apart. We know that is 500 miles, we're given that. Car 1 and car 2, D1, D2. And what do we know about the cars? We got V1, D1, and T1. Car 1 is going 55 miles an hour. And we don't know the distance and we don't know the time. And for car 2, we got V2 equals 63 miles per hour. And we don't know anything about the times, but we do know that they both spend the same amount on the road. So T1 equals T2. And we know D1 plus D2 equals 500 miles. So we start with the usual, D equals VT. And we know D1 plus D2 equals V1 T1 plus V2 T2. Just rewriting D1 as V1 T1 and D2 as V2 T2. And this D1 plus D2 is 500 miles. And we know they spend the same amount of time on the road, so you can replace the T1 and T2 with the generic T, because it's the same numerical value. We got 500 equals factor out of T, V1 plus V2. Dividing each side by V1 plus V2 gives you 500 over V1 plus V2. T for both cars, time for both cars is 500 divided by 55 plus 63. Time is 500 over 118. Figure that out, it comes out to be 4.237 hours. And 0.237 hours is about 14 minutes. So the time for both cars, they're on the road for about 4 hours and 14 minutes. And the question is, what time is it when they pass each other? They started at 4 o'clock, add 4 hours and 14 minutes to that. So they pass each other at approximately 8:14 p.m. In this problem, we have car 1 goes from point A to point B in 3 hours. Car 2 goes 20 miles per hour faster than car 1 and goes from B to A in 2 hours. Find the distance between A and B. We'll make this A, and we'll have B over here. And what do we know? Car 1, we got V1, D1, and T1. We don't know V1, we don't know D1. We know T1 is 3 hours, and V2, D2, and T2. We don't know V2, but we do know that it goes 20 miles per hour faster than V1. So we can write V2 as V1 plus 20 miles per hour. Don't know D2, and we know T2 is 2 hours. And we also know that going from A to B is the same distance as going from B to A. So D1 equals D2. And we can rewrite these as V1, T1 equals V2, T2. And V1, T1. And we know V2 is, rewrite V2 as V1 plus 20 times T2. Expand this out. We got V1, T1 equals V1, T2 plus 20 T2. And we're going to have to solve for V1. So that means bringing V1 over here, we'll have V1 T1 minus V1 T2 equals 20 times T2. Factor out a V1. These with T1 minus T2 equals 20 T2. And plugging in some numbers, T1 minus T2 is 1. So you have V1 equals 20 times T2. T2 is 2 hours, so that makes 40. So we know V1 is 40 miles per hour. And I didn't give myself much room to do this one. But V1 is 40 miles per hour. V2 is 20 miles per hour faster. So that makes that 60 miles per hour. And you can use either one of these to figure out the distance between the points A and B. So for D1, we have D1, V1, and T1. So D1 equal 40 times T1 is 3. Distance between A and B will be 120 miles. Hope you can all read that. That's what it is, 120 miles from A to B. Here we have 2 cars are heading for each other, and they both start at 9 a.m. Car 1 is going 60 miles per hour, and car 2 is going 20 miles per hour slower. They pass each other at 2 p.m. How far apart were they to begin with? And how far were they to begin with is D. That's what we're going to have to calculate. So it will be D1, here's car 1, car 2, and D2. So what do we know about these cars? We got V1, D1, and T1. V1 is going 60 miles per hour. D1, don't know. T1 we can figure out. They start at 9, both cars start at 9, and they pass each other at 2 p.m. So that's 5 hours on the road for each car. And what do we know? V2, D2, and T2. V2 tells us, problem tells us that car 2 is going 20 miles per hour slower. So this is 40 miles per hour here. Don't know D2. And T2 is the same. It's also on the road for 5 hours. So we have D, which is equal to D1 plus D2. Equals V1, T1 plus V2, T2. And the time is the same, so we can just replace it with a generic T with no subscript. And D1 plus D2 is D, the distance they are apart. We have V1 are regular T's and V2 regular T. And factor out a T. We'll have V1 plus V2. So D. And stick in some numbers. 5 hours times 60 plus 40. Distance apart. So 100, 500 miles. They were 500 miles apart when they began. And here's our last car problem in the series. Car 1 and car 2 are 200 miles apart, heading for each other, and both are going 60 miles per hour. After 1/2 hour, car 2 gets stuck in traffic for 45 minutes, and then continues traveling at 60 miles per hour. How far did each car travel when they pass each other? Let's make this car 1, and this will be car 2, D1, and D2. And we know that this is the distance they are apart. D equals 200 miles. And what do we know? What do we know about the cars? V1, D1, and T1. V1 we're given at 60 miles per hour. Don't know D1, and we don't know T1. And for car 2, V2, D2, and T2, we're given 60 miles per hour here. Don't know D2 or T2. And figuring out the time is what's a little bit tricky here. Both going for 60 miles per hour heading toward each other. After 1/2 hour, car 2 gets stuck in traffic. So the first half hour, they're both moving towards each other. And let's say this is the half hour mark for this car, and say this is half hour mark for this car. So you can write time for each one is now 1/2 hour at that point. And then car 2 stops for 45 minutes, which means car 1 is still going an additional 45 minutes. Say that's the additional 45-minute mark. So you can add 45 minutes to car 1's time. And don't forget to put the minutes into hours. And that's 3/4 of an hour. So car 1 is up to 1/2 hour plus 3/4 because it doesn't stop at all. And car 2 is still stuck at 1/2 hour. And then it starts moving. Car 1 is already in motion. So the distance from the 1/2 plus the 3/4 hour to the rest of the time where they meet is unknown for each car. But it's the same time for each car. Again, they're both start in motion for a half hour. So I got 1/2 hour clocked. Car 2 stops, but car 1 keeps going another 45 minutes, so it gets another 3/4 of an hour for its time. And the rest of the time, they are both in motion until they meet. and it'll be the same time from the time car 2 starts up again to the time car 1 goes past the 45-minute mark, and they meet here. You can call this X amount of time, but X1 will be the same as X2. So you can just add X to both cars' times. Once again, they both move for a half hour. They got a half hour clocked on each one. Car 1 moves for another 45 minutes. It gets a 3/4, while this one's standing still in traffic. And the rest of the time is the same for each. Once car 2 starts going again, they're on the road the same amount of time, and you can call that X. And that's what we have to solve for. So we have a complete total time for each car, and then we can calculate what the distance is that they drove. So we have D1 equals V1 T1, and you can write that as V1 times 1/2 plus 45 minutes, 3/4, plus X, the unknown amount of time it takes to finish up until they meet. And we have D2 equals V2 T2. And D2 will be V2, and T2 is the 1/2 hour it went at the beginning, plus the unknown time it took to get to the point where they meet after the traffic cleared up and car 2 keeps going. So we have D1 plus D2 equals V1 times 1/2 plus 3/4 plus X plus D2, V2 times 1/2 plus X. And we know D1 plus D2 is given, it's 200 miles, equals, expand all this, V1, get 1/2 V1 plus 3/4 V1 plus V1X, plus expand this out, 1/2 V2 plus V2X. And simplifying these things a little bit, we have 1/2 V1 plus 3/4 V1 will be 5/4 V1 plus V1X plus 1/2 V2 plus V2X. Take everything that does not have an X and stick it on the left side. We have 200. Subtract 5/4 V1 to both sides. Get 5/4 V1 here. And subtract 1/2 V2 from both sides. Takes care of that. And you're left with, on the right side, V1X plus V2X. Got 200 minus 5/4 V1 minus 1/2 V2 equals, factor out an X, and get V1 plus V2. And dividing both sides by V1 plus V2, got 200 minus 5/4 V1 minus 1/2 V2 equals X, and divide this left side by V1 plus V2 and X, and this all will be the unknown amount of time it took for both cars to finish until they meet. And we can stick in some numbers here. We'll have 200 minus 5/4, and we know V1 is 60, minus 1/2, V2 is 60. Be all over V1 plus V2 is 60 plus 60. And we'll have 120 in the denominator. We'll have 200 minus 300 divided by 4, 75. And minus 30 equals x. And that'll come out to 95 over 120. And simplifying that, it'll be 19 over 24. 19 over 24 hours is the time it took for both cars to finish. So we can use this value for x to find the time for each car. So T1 equals 1/2 plus 3/4 plus 19 over 24. And that comes out to be, common factor would be 24. And that'll leave us with 12 plus 18 plus 19. T1 equals 20, 30, 49 over 24 hours. Problem is asking, how far did each car travel when they passed each other? Now we know T1, we can figure out D1. So D1 equals V1 T1. D1 equals 60 miles per hour times 49 over 24 hour. And you figure that out, it comes to 122.5 miles. And also using x, we can calculate T2. T2 equals 1/2 hour plus 19/24 hour. And common denominator 24. We get 12 plus 19. T2 equals 31 over 24. And from T2 we can figure out distance car 2 traveled, V2 T2. So D2 equals 60 times 31 over 24. And that'll come out to 77.5 miles. And as a check, when you add D1 plus D2, 122.5 plus 77.5, that adds up to 200 miles, which is the distance they were apart to begin with. Thanks for watching, and I'll see you again next time.